A polynomial can be classified according to how many terms it has, or really, how many monomials it includes. So this is the one we talked about yesterday. One term. This is all one piece because there's no addition or subtraction. It can all be connected by multiplication or division. This is one piece. It's called a monomial. Mono meaning one, because that's all one number. This has two terms. So I need a prefix that means two numbers. Binomial. Now this one has 1, 2, 3 terms. So it's going to be a trinomial. And then we get to this one now. When we get past 3, they don't have special names anymore. I don't know why. I'm not sure why we don't call them quadrinomials or tetranomials, but we don't. They're all just polynomials after that. So 4 or more terms are going to be polynomials. It could have 100 terms. It doesn't matter. It's going to be a polynomial after 3. All right, so yesterday we also talked about degrees of a monomial. Remember, the degree is the exponent on a variable. Well, the degree of a monomial, the degree of a polynomial is equal to the highest degreed monomial. And that's because you're going to have multiple degrees in each one, because you have multiple monomials. Now, the first one they did is a monomial. Remember, you look at the variables and add the degree, or add up the exponents, so that's where the degree is 5. So the degree of the entire polynomial is considered to be 5. So on this binomial, you have 2 separate degrees. A degree for the first monomial, so it's 2, and the degree of the second monomial is 1. The degree of the polynomial is just the highest number. You do not add them together. So the polynomial is a second degree polynomial. So this trinomial, 3 terms, 3 degrees. So the first one is to the second degree. This is to the first degree. And then a constant has no variable. So the degree is 0. Because remember, you're looking at the exponent on the variable. So this is a second degree polynomial. Alright, now here's where it gets a little crazy, because we have multiple variables in each term. So my degree of my first term is 5. Because the A has a 4 and the B has a 1. And you have to add those two together because it's all in the same term. The degree of the second term is 3. B has a 1, C has a 2. The degree of the third term is 2. C has a 1, D has a 1. And the degree of the 8 is 0 because it's a constant. Constants don't have a degree. So my polynomial is a 5th degree polynomial. Everybody okay? All right. The stuff about degrees is going to come into play later on. You need to know it. I'll say it from time to time. I'll say it's a whatever degree. This is that degree. But we don't use it until later in the year, but we will. Okay, so now what we're going to do is a review of simplifying polynomials. We're simplifying with addition, subtraction, and multiplication. We don't divide polynomials until later because it's a little bit harder. But all this stuff you've done before. So the first thing we're going to do is clear any grouping symbols that we happen to have. This time most of our grouping symbols happen to be parentheses. So we're going to clear them with distributive property if we need to. Then after that you combine like terms. So looking at number 1, I have this first set of parentheses, but there's nothing listed in front of it. So there's no distributive property here. Those parentheses there so that you know, hey, this is a trinomial. This trinomial all belongs together. Who knows why, but it does. So that first set, you can actually just drop them off because there's nothing in front of it. There's no reason even for them to be there. So I'm just going to write this as negative 4x squared minus 3xy plus 5y squared. No parentheses anymore because I don't need them. But my second set of parentheses is there to show distributive property. So I'm going to go ahead and distribute plus 6x squared minus 6xy minus 10y squared. So we just took care of bullet number 1. We cleared the grouping symbols. Now we want to combine like terms. Now in order to be like terms, what has to be true? Variables have to match. And the degrees on the variables have to match. So for x squareds can only go with other x squareds. So negative 4x squared plus 6x squared. We're combining, which mathematically means add. So that would be 2x squared. Then I do xy's. So when you're trying to, go ahead and try and do it in order, because if you do it in order, then you don't have to rearrange it when you're finished. Good algebraic order. Descending exponents. That means you find the highest degree and you count backwards. So if you had something to the 4th power, that would come before something to the 2nd power, right? Highest exponents come first. And alphabetical order of variables. So x's come before y's. So before I add my y squares, I got to take care of anything that has an x in it. So I'm going to do my xy's. So negative 3xy minus 6xy would give me minus 9xy. And then I can do my y's, and that gives me minus 5y squared. Is everybody okay? So when I'm talking about the order, you do all of the x family first. If there's any x's, you try to get those out of the way, and then you do the things that just have y. Okay, on problem number 2. I'm kind of in the same situation. That first set of parentheses, I don't really need. It's just there for, just say, hey, this is a trinomial, so I'm going to go ahead and drop off the first set. But the second set I do need. It's there so that you don't forget to distribute the negative or distribute the minus sign. See, because we want to combine things, and combine is addition. So I don't want a minus sign. So I'm going to distribute it through, and then it's gone. So that makes this plus x squared minus 5xy plus 2y squared. Combine like terms. 3x squared and x squared is 4x squared. 6xy minus 5xy is 1xy, but you can just put xy. And then your y squareds minus 5x squared. That's it? Everybody good? Mm-hmm. Okay. So we need to clear the grouping symbol. So on number 3, the grouping symbol is there to indicate multiplication. We want to multiply this monomial by this binomial. So I'm going to distribute. Don't forget all the stuff we talked about yesterday. Multiply coefficients. So it's going to be a 15. And what do I do with my exponents? Add them. So this is going to be x cubed y cubed minus 18 x squared y to the 5th. And that is all you can do, because they are not like terms. So I cannot add them. Everybody okay? Mm-hmm. All right, what about number 4? What should I do? Do y'all remember? Foil. Now, I told 6th period, I will say foil, but you guys, I hope you understand that foiling is just distributive property. And the reason that's important is because FOIL only works with 2 binomials, F-O-I-L. But what if I have a binomial and a trinomial? See, that's F-O-I-L, and I have an extra number. So foiling only works when you have this, two binomials. So you need to be aware that it is just distributive property. And I will show you what I mean. I multiply this, so I'm going to ignore this 8 and just distribute the x into this. So x times x is x squared. X times minus 3 is minus 3x. And then I'm going to just ignore the x and distribute the 8. So I will be plus 8x minus 24.
Where's the football boys?
Which is the same thing that you would have gotten if you did first times first, outer, inner, last. It's the same thing as FOIL. So then we combine like terms and I get x squared plus 5x minus 24. Okay, now I'm going to do one, I'm going to write one in right here because on your assignment in just a minute, you have a binomial times a trinomial. So I want to do one just so you can see what I mean. So let's say you have x plus 2 times 2x squared minus x minus 1. You cannot FOIL. Too many terms. FOIL is only 4 letters. I have 5 terms, so that won't work. But I can distribute. So x times 2x would be 2x to the what? Third. What do you do with exponents when you multiply?
You add.
There's 1 here and 2 here, so it's going to be 2x to the third. X times x would be negative x squared. X times 1 is minus x. Now you're not done because all I did was distribute the x. I still have to distribute the 2. So now I'm going to do this. 2 times 2x will be plus 4x squared. 2 times negative x is negative 2x.
Please pardon this interruption, but I am going to ask all of you wonderful students at Brady High School if you would please, in the morning, park at the far end of the parking lot by the middle school. When you come to school, I would appreciate it because we're going to have a lot of guests who are older, who need help getting in to the school. And I would really like them to park near the snack bar. So if you guys could just take available spots back there, I would greatly appreciate it. Thank you.
And then you combine like terms. Okay? So it's a little bit, if you have a binomial and a trinomial, it's going to come out a little bit. Make sense? It's just distributive property. Don't let it bother you. Sometimes they get a little messy. You just have to kind of keep track of where you are. Okay, number 5. Yesterday, we were taking the exponent on the outside and putting it on each piece. We could do that because yesterday we only had 1 term inside the parentheses. That's not 1 term, it's 2. So you can't do that. Instead, what does squaring something mean? Multiplying it by itself. So that's really what this is. So I would, to avoid making mistakes, I would just write it down twice. Because that's what this means, x plus 4 times x plus 4. Then you just FOIL it, or distribute it, and that would give you x squared plus 4x plus 4x plus 16, which simplifies to x squared plus 8x plus 16. Which is very different than if you had just put the squared on both pieces. Because that would have just given you x squared plus 16. You'd have missed that whole 8x piece. Alright. This will catch you at some point in time, I promise. It does everybody. But I'll just tell you, what does it mean to square something? Okay. On this one, these are what we call conjugates of each other. Because they have the same terms, 2x and 2x, and 3 and 3. But one is a plus, one is a minus. Conjugates are real nice and simple. Because when you get a conjugate, you don't have to FOIL, you just F and L, that's it. Because the O and the I are going to cancel out every time. So it just saves you a little time, it's a little more efficient if you just go, okay, well F, that's 4x squared, and L, minus 9. Don't even have to mess with the O and the I, because they're going to cancel out every time. problem? Rectangle with a width of 4x plus 5 and a length of 3x plus 2. What expression can be used to represent area? Area of a rectangle? Length times width, or base times height, either way, it doesn't matter. And they gave me a length of 3x plus 2 and a width of 4x plus 5. So you just have to distribute this or FOIL. And then combine like terms. Last one. Diagram shows an isosceles triangle. What does that mean?
These two are the same.
These two are the same, the legs are the same. So I have two of those, and they're asking me to find the expression that represents perimeter, which is just all the way around. Instead of adding them all up, I have two of these, so I'm going to write it as 2 times 3a plus 5, and then add to that the base, which is 3a squared plus 2a minus 1. And that should give me the perimeter. So now, according to the instructions, we got to get rid of the grouping symbols. First grouping symbol is there to indicate multiplying. So that would be 6a plus 10. The second set of parentheses I don't really need, so I can just drop those off. I'm going to combine like terms, but I'm also going to put this in the correct algebraic order. So what should go first? The 3a squared. And it doesn't have anything else to go with it, so I'm just going to move it to the front. And then the a's, so it'll be plus 8a. And then 10 and negative 1, so plus 9. Everybody okay? Alright, so go. You might be able to finish it. Several people finished it.
Another sheet of paper.
Do what?
Do it on another sheet of paper.
Yeah, if you need to. It is a little cranky. Kind of small.
Are you going to the game?
No, because Keys is speaking at the middle school Veterans Day.
Oh, really?
thing. Yeah, he's got one of the little speaking parts.
Oh, okay.
That's cute.
Is he nervous about it?
It didn't seem to be.